Yes, good morning, everyone. Welcome to our today's class. I'm sure that you did already your class activities and you submitted them to COSO. From next week, you're going to get all your results, right? We were doing chapter 4, and for you guys, I will be there on Friday morning. So we are going to practice. We are going to finalize with chapter 4, as most of the stuff are related to coupling. So on Friday morning, I will be in Durban, and we are going to practice. Sorry, guys. So we are going to come with some of the devices for us to practice also on how to create some of the lens and right. And beside that, today we are going to move on. We are going to continue with chapter 5. As I said, chapter 4, we are going to finalize on Friday. So I will be there on Friday, and we are going to finalize with chapter 4. That's why we have to move to chapter 5. We cannot wait for Friday, right? Let's move on to chapter 5. So chapter 5, it's very, very easy and short, even though it's all about calculations, but it's very easy and short. So we're going to start this chapter now and be done today. And I've sent a document on WhatsApp. You can try to open it like on your computers and try to follow together with me, right? And there are so many exercises. You have to finish up those exercises and submit your work to non-Tokozo, right? Let me try to share my screen. Yes, we are going to talk about number systems, right? As you know, computers cannot speak English. Computers cannot understand English. Not only computers, even your phones. So all the electronic devices cannot speak our languages or even understand those languages, right? So your computers, your switches, your routers cannot speak English, cannot understand English, or your isiZulu, right? So computers will use their own languages, what you have to understand, right? So shortly, we are going to talk about number systems. As I said, computers cannot understand our languages. We need to use their own language, right? Computers will use what we call binary language, binary or machine language, right? Let me try to, okay. Did you understand? Now, because computers, they're gonna use their own language, you need to understand, you as a specialist, you as an engineer, you have to know how to represent those numbers and how to manipulate them. At least you have to understand the language that the computer or your devices will use and how your devices will manipulate those numbers, right? So you have to be able to understand which language your computers will use, your switches, your routers, and how they are going to manipulate those languages, right? This is what we are going to do. So you can see here, I got my table here, right? So as I said, we are going to talk about binary language. So computers use what we call binary language, right? You can see here it says binary. Binary will have only two states or base 2. We'll use only two state means on or off. Sometimes we can use 1 or 0. So 1 means on, 0 means off. So binary language will use two state of two numbers, 1 and 0. 1, it means like on, and 0 means off. So there is electricity, yes. Yes means 1, and no means 0 or off, right? So binary language means base 2. Base 2 means two numbers, 1 and 0. So shortly, computers can only use 1 and 0, right? What does it mean? It means whatever that you are doing with your devices, whatever that you are saving, can only be represented by using two numbers, 1 and 0. So when you are typing a long message, that message will be converted to thousands of what? 1 and 0, right? So whatever that we are doing with computers, sending and receiving messages, saving and so on, your computer can only see what? Millions of ones and zeros. So for computers to understand whatever that you are talking, whatever that you are typing, computers need to convert them in what? 1 and 0, right? As I said, the language that computer can use and understand is the binary language. And that language will only use two numbers, 1 and 0. And the reason why computer can only use 1 and 0, not only computer, but all the electronic devices, such as your switches, your routers, your modem, and so on, right? When your computer will use only two numbers, 1 and 0, your computer will be fast, right? So instead of your language that uses maybe 26 letters and so on, right? So everything will be converted to 1 and 0. You can write a long sentence, but that sentence will be minimized, will be converted to 1 and 0, but millions of 1 and 0. And your responsibility now is to know how to represent those numbers in binary, how to convert a specific number to binary, right? And when computers will use 1 and 0, your computer will use less storage. That way you can see a single computer like this, but that computer got thousands of words or thousands of stuff inside. Why? Because whatever that you are representing can only be represented as 1 and 0, right? So you can see the language that is used by computer, we call that language binary language or machine language, right? Do you understand? So computers can only understand 1 and 0. Why? Because they wanted your computer to be fast and use less storage. So when you are saving your picture, I'm sorry to tell you that no matter how beautiful your picture is, your picture will be represented as ones and zeros. So your phone can only see millions of ones and zeros, but you can see a nice picture, but your computer can see thousands of ones and zeros, right? So binary language base 2. And the second one is a decimal notation. Human beings, for counting, they are using decimal system, right? And decimal system is base 10. Base 10 means 10 numbers. Human beings are using 10 numbers for counting. Those numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the 10 numbers that human beings will use for counting, right? And human being uses their own languages like English, French, like Isizulu, like Afrikaans, and so on, right? So decimal is base 10. Now your responsibility is to know how to represent number 10 in binary, how to represent number 100 in binary, how computers can see number 100, right? This is what we are going to do. We are going to see how to convert from binary to decimal, how to convert from decimal to binary. When you know those calculations, at least you will know how your electronic devices will represent some of the numbers or some of the characters. There is also what we call the hexadecimal. The hexadecimal, this one is base 16, right? Base 16. Base 16, there is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From 10, number 10 is represented by A, number 11 is represented by B, and number 12 by C, number D by 13, number E by 14, number F by 15. So the hexadecimal system will have 16 number of characters, right? It's base 16. From 0 to F, you have to know that number 10 we represent it by using A. Number B, this is 11. Right? Number C is 12, number D is 13, number E is 14, F is 15. Right? Why we need hexadecimal? We need hexadecimal for our physical address. You remember that your physical address or your MAC address will be like 2AF, something like that, right? We need it because your MAC address, your physical address of your phone, of your laptop, of your switch, will have what? Will have a physical address. Your switch will have a physical address. And that physical address or your MAC address, when you represent it, that form will be in hexadecimal form. Now you have to learn about this hexadecimal system, right? So what I've said, I said this, your switch, your phone, your computer will have its own physical number, unique number that you cannot change. That unique number, we call it MAC address. Now, how to represent that MAC address or that unique number of your phone? You're going to represent it by using the hexadecimal, right? And that hexadecimal is the mixture of what? Letters and numbers. That way you have to know how to convert or how to manipulate the hexadecimal numbers or system, right? Now, let's move forward. Number one, we are going to see how to convert from decimal to binary, right? How number 10 can be seen by your phone. How number 10 can be seen and manipulated by your phone or by your laptop, right? You have to understand what is number 20, right? Number 20 will be seen like this, like a binary, right? This is what we are doing, right? Because when you are using your IPs and so on, your IPs from your electronic devices, from your switches, they cannot see that 192.168.1.1. They can only see binary numbers, right? But you as a specialist, you have to understand how to manipulate them, right? Okay, you're gonna use this table for you to convert, right? You start by 1, double of 1, it's 2, double of 2, it's 4, double of 4, it's 8, double of 8, it's 16, double of 16, it's 32, double of 32, it's 64, double of 64, it's 128. You need to have this table first, right? So you have to write this table down. 1, 2, 4, 8, 16, 32, 64, and 128. When you have this table, right? When they will ask you, like this one, when they will ask you, like to convert this, we're gonna say, convert like 86 in binary, right? They will ask you to convert this number 86 in binary. What's gonna be number 86 for your phone or for your computer? How your computer will interpret number 86? You got your keyboard, you type 86. How your computer will understand it and how the computer will manipulate it. What is 86 for your computer? Because computer cannot see that 86. There's a conversion that will happen, right? Now, how to convert this 86? This 86 is a decimal number for us. Now we want to convert it to binary, right? Now you go to your table here. How to get 86? For me to get this 86, what I'm gonna do, I'm gonna take first 64 So where there is 64, I'm gonna put 1. 64 plus what? 64 plus 16. So what's gonna be? It's gonna be like 64 plus 16 is 80. So it's gonna be 80. So I have again to add 4. 84. And I'm gonna add what? 2. Right? So for me to get that 86, so I have to do 64 plus 16 plus 4 plus 2, right? That's gonna be 86. So it's what? From me, you're gonna put what? You put 0, then you put 0, and then you put 0, right? So your 86 in binary is what? It's 1 0 1 0 1 1 0. This is your 86 in binary. So when you are typing on your keyboard 86, your computer can see what? Your computer can see 1 0 1 0 1 1 0. Automatically your PC will know that this is 86. Right? Let's take another example. Right? Let's convert number 17 in binary. Right? You go back to your table. How can I get 17? Right? So 17 is what? 16. You put 1. 16 plus what? 16 plus 1. That's going to be 17. So there it's 1. And here 0, 0, 0. Right? So 17, like in binary, it's what? 1, 0, 0, 0, 1. Right? This is 17. Very, very easy. Right? Let's take another example, the last one, and I'm going to let you do your own exercises. Right? Let's do the last one. Let's convert 200 in binary. How computer will see 200, right? For me to get 200, I can take 128 plus 64. That's gonna be maybe 192. 192. So I need 8. That's gonna be 200. So I'm gonna put 1 here, I'm gonna put 1 here, and I'm gonna put 1 here. So here I'm gonna keep 0, 0, 0, 0, 0. Right? So 200 in binary is 1, 1, 0, 0, 1, 0, 0, 0. Right? So this is what you have. But if there are zeros, like in front of this one, like only 0, 0, 0, 0, there's no need for you to keep those zeros. But if there are zeros behind this one, you have to write them. 0 behind, you keep them. Zeros, like series of zeros, like in front of 1, there's no need, right? Okay, those are the exercises that I wanted you to do. You have to do those exercises. You have to convert below numbers in binary, following the method that I've explained. When you are done, you submit your work, right? Let's move now how to convert from binary to decimal. How to go from binary to decimal, right? Very, very easy. Like this one, they want you to convert this one. 1 0 1 1 1. Right? How to go now from binary to decimal? 1 0 1 1 1. Right? How, which number is going to be this one? use the same table, right? You start here, the first digit is 1, you put 1 there, right? You move, you put again there what? You put 1, there's another 1, you put what? 1, there's another 0, you put what? 0, and there's another 1, you put 1, right? So what's gonna be now your number? You take this one, 16 plus what? Plus 4 plus what? Plus 2 plus 1. So it's gonna be what? 16 plus 4, it's what? 20. 20 plus 2 is 22. 22 plus 1 is what? 23. Right? So this is 23. So these binary numbers can only give you what? 23. Let's take another exercise. Right? Okay. This is what you have to do, right? I can give another example, or maybe if you don't mind. Let's say you got this one. Okay. They want you, which number is this one, right? Which number is this one? What you must do, let me find the table here. Right? There's 1, 2, 4, 8, 16, 52, 64, 128. For me to get this answer, right? What I'm gonna do, I'm gonna just pick up these binary numbers. You come here, you say 1, followed by 1, followed by another 1, there is 0, 1, there is 1, there is another 1. All right. So you only keep what? 64 plus is 32 is 96. 96 plus 16. 96 plus 16, it's 112 plus 4, it's 116, 118, and 119. So it's going to be what? It's going to be 119, right? So if I'm mistaken, you can fix it, right? Because I'm recording, sometimes I can be wrong, right? So this is how you have to convert from binary to decimal and from decimal to binary. You got the exercises, do them, and I'll send the last recording before the end of the day, right? Okay, thank you very much. For any questions, don't hesitate to contact me. You see their exercises here, I have to do them, right?